Markov chains are extensively used in modeling sports, that is for sports betting. So here we will consider a very simple example. The future depends upon past two states, xn and xn minus 1. And you could have any number of past states and the future could depend upon them. So here we will consider an example of a basketball player. So the basketball player hits a shot. So the probability of next shot going into the basket depends just on the past two shots. So the possible states for the past two shots are either he hits it or he does not hit it. So this is a not sign, that means misses it. So there are four possible combinations. So both the past two shots were hits. So we are going to write it like this, T0 and T1. So these are the past two and T2 will be the future. So in xn minus 1 stage is T0 and xn stage is T1. So you had a hit in both the past two states. So that is state 0. State 1, he had a miss at T0 and at T1 there was a hit. 2, there was a hit in state 0 and a miss in state 1. And 3 is both the past two shots were missed. Now we assign some probabilities. So P00 is 0.7, that is the next shot is a hit given there were past two hits. So this P00 you write it like this. So remember Pij, I is initial, j is final. So I is your initial state and Pij is the probability for going from I to j. So P00 means, so first 0 corresponds to these two hits, H and H. Second 0 corresponds to these two hits. So notice that there has to be a common in between. Only then you can paste them together. 0 means last two hits and then there is a hit. So this is P00. So this is given to you as 0.7. So this is 0.7. Then we are given P10 as 0.5. What is P10? So P10 means, so here is P10. So first you have 1, that is not head and a head. So that is what we are writing. P1 is this, not head and a head, and 0 is two heads. So 0 is these two heads. So that is the third shot is going to be a hit, considering that you did not have a hit in the xn minus 1 and in xn you had a hit. So this is given to you as 0.5. P21 means 2 is head, not head. So first focus on 2. 2 is head, not head. I'm just copying this down. And then 1 is a not head and a head. So not head is a common one and then you have a head. So this is P1 2. So this becomes P21. So P21 is head, not head and a head. So head, not head and a head. This is given to you as 0.4 and P31 is 0.2. P3 is last two were misses, but now what is the probability he would sink the basket? So this is P31. So P31 is not head and a head. So 3 is not head. This is not head, and 1 is not head and a head. So 1 is this, not head and a head. So notice you're able to have a common ground in between. If you do not have this common, this thing will not work. So you have to remember in Markov chains, when you paste probabilities like this, every time you're talking about two states, this 0 is also about two states and this 0 is also about two states. And so notice how we glue them, H, H and then H, H. So similarly not H and then not H and H. So how do you get these probabilities? These probabilities just come from analyzing big data for the past game. So you take a player, see his 3 shots and classify them in different states. You classify them as, when did he have 3 hits continuously? When did he have a hit, not a hit and a hit? 2 not hits and a hit, not hit, hit and a hit. So you can classify this. This you can get from big data, so you can do it game by game analysis. This is how people who want to bet in sports will do game by game analysis of the players' hits and misses. So this is big data analytics. So a lot of people just talk about big data analytics without even knowing what analysis they want to use. So here we are showing how to use big data analytics. So now you have these 4 states. So P00 you have, then you have P10, P21 and P31. So let us write this in a matrix form. So this is the general matrix form. So this is a 4 stage. So there are 4 stages here. So the stage is 0, 1, 2, 3, 4 stages, and 4 stages here, 0, 1, 2 and 3. So notice you just write it in a matrix form like this. So this is always going to, so you can have a 4th stage here is right here. You can have a 5th stage which you will write as 4. Then you will have P40, P41, P42, P43. But then you have to add the 5th stage here also, and then this will be, there will be another column here. So this is always a square matrix, and this is the format of the matrix. You should memorize this format. So this is always row and column, 0, 0, 0, 1, 0, 2, 0, 3. So this is how it works. And always the sum of the entries in the row is 1, because all of this corresponds to a particular state. So it corresponds to a particular state here. So you have to think of this row wise. So the rows will add up to 1. So this is a very important point in a Markov chain. Rows add up to 1. So you always start with the initial state 0, 0, and this is how it looks like, and rows will add up to 1. This is very important to remember. So you are given P00 as 0.7, so you feed in 0.7 here. P10 is given to you as 0.5, feed in 0.5 here. Then you are given as P21 as 0.4, you feed in 0.4, and you have P31 as 0.2, you feed in 0.2. Now these we have to find out, because the sum has to add up to 1. So 0.7 plus 0.3 is 1, 0.5 plus 0.5 is 1, this is 1, and this is 1. But how do we assign these values? So let us assign these values. So P00, what is the complement of P00? So the final state is head. So notice that the final state is head. So P00 is head, head and head. So this 0 is the past, this was the head in the future. So the complement to this is, you again have the same past, that is head, head, and the complement is not head, because there is a head here, so not head is the complement. So this HH corresponds to 0, but H not H, H not H we have to find here. H not H corresponds to 2, and that is what becomes the idea here. So P02 is H not H. So 0 is HH and 02 is H not H. And find P02 here. P02 lies right here. So this P02 would be 0.3. So 0.3 is complement of 0.7. So 1 minus 0.7 is 0.3. Now you have P10. So again P10 is like this. P10 is not H. I'm copying this down now. H and H. So this is the past, this was the short. So complement of this is this complement of this. You have to put not H here. This you just copy it like this. Not H and H. So this was your past. This past is 1, and this H not H is your future. H not H. So H not H is again 2. So so you have this right here, not H, H, not H. So this is not H, H and not H. So P12. So P12. So P12 is right here. P12 is 0.5, 1 minus 0.5 complement. So again we are given as P21 as 0.4. So this is P21 as 0.4. I've written 0.4. We want to find complement. So there are 3 things. This 2 is the past. These 2 are the past. This is the H. So complement, when we find complement, you find complement of the future. So this will become not H. So this becomes past is copied. This I'm copying as such. This H becomes not H. So not H is what we want to look for. Not H is 3. So this becomes P23, because 2 remains as such and then 3. So you fixed the row. So you always find the complement in the fixed row. So P23 is right here. So 1 minus 0.4, you get 0.6. You add them, you get 1. Now the final one, you have P31 and P33. So P31 is given to us as 0.2. What does P31 mean? 3, you have not h, and then you have 1, which is not h, h. So P31 I have written right here, not h, and then not h, h. So again, you are in third row, you keep the path as such, and you change this h to not h for the complement. So you have not h, that is 3, and then these two, what is this? Not h, this is also 3. So P33 right here. So this is 1 minus 0.2 gives you 0.8. So now you have the transition matrix. So this is how you construct a transition matrix. So you see a lot of effort has gone into building such a simple Markov chain. So now let us come to the probabilities. So if a player has 2 hits, what is the probability that the 4th shot will be a hit? So he has taken 2 shots. What is the probability that the 4th shot will be a hit? Now notice that it may be a hit or a miss on the 3rd shot. So the 3rd shot could be either a hit or a miss, but you want a hit on the 4th shot. So now let us come back to our states. So we want the final shot to be a hit. So let us see which are the final shots which have a hit. So 0, this is the final shot, it is a hit. Okay, this is my this I have to keep in mind. Here in 1, the first shot was a not hit, but the final shot is a hit. So this is also in my consideration. This 2, the final shot is not a hit. So this is not in my consideration. I want a hit. So because we want the 4th shot to be a hit. So this is not a hit. So this is not in my consideration. 3, both the shots are not hit. So final shot is a not hit. I don't have this in consideration. So only 0 and 1, because the final shot could be a hit here. And the 3rd shot could be a hit in 0 case and not hit in this 1 case. So you have 2 probabilities. So first probability is associated with, you start with 2 hits, you end up with 2 hits. So you start with you have 2 hits, and then you end up with a hit. You start with the hit, end with the hit, start with the hit, end with the hit, start with 0 hit. 0 means 2 hits, and you end with the hit. So this is this. Or you again could have 2 shots, and now you have 1 0 0 1. Again you could have again you have 2 hits here. Again you have hits here, because when you are repeating 1 1, you again having 2 hits. So you have hits. So you start and you end with 1, start and end with 1, start and end with 1, start and end with 1. So basically our idea is you end with either 0 or 1. So these are the 2 possibilities. So how do you get it? It is nothing but you multiply this matrix by itself. You multiply the matrix by itself, then this comes by multiplying the first row. This you multiply with the first column, you get this. And for this, you take the second row and you multiply it with the second column. You will get this. So this is basic simple matrix multiplication. Then you compute p square. This element is right. So this element in blue, this one will become 0.49. This is this element, and this one becomes 0.21. This is this element. So notice again that how much effort has gone into making this small matrix work. So our total probability is just sum of these two, and if you sum these two, you will get 0.61. So let us do this in R now. So you have the matrix here, and then we are just multiplying it, and then we are just adding the first row first column and first row second column. So let us run this. So this is the matrix we get, and 0.61 is what we get. So this is how you can compute probabilities for betting in sports. So if you are given if you have done your data analytics correctly, you see that there is a good probability, it's more than 0.5, so it is advisable to bet. The odds are in your favor.